we talked about predicting with EWMA, and that's when you use the last value over here and the last value over here, and then those lambda and 1 minus lambda. But you can also predict, let's say, predicting time series using regression. Predicting time series using regression, right? And you may say, how in the world do we do that? Because, you're given certain data and that's time, like time. How do you, well, we're going to say we can predict one time point outside of the data using regression. So not only can we predict one time point using EWMA, we can also predict one time point outside of data using regression. Okay, so I'm going to look at this example. I'm going to look at this example and I'm going to make it up. Suppose you have this. Let's say our time, and we're going to actually put this in Excel, I guess. Well, let's see. Let's say Monday, Tuesday, Wednesday, Thursday. And let's say this is the data here. Oh, I don't know. Let's just say data. I don't know if it's sales or revenue or whatever. And let's just say 250, 200, 310, and 400. Well, normally when we talk about running a regression, I mean, it's often, we do the regression on Excel, like this is the Y we put in, and then this is the X that we put in. Yeah, well, you see the problem. How do you put in Monday, Tuesday, Wednesday, Thursday in Excel? I mean, these are words. We normally have numbers right here when we do Excel. So what we're going to do is do like a short caveat or a short change when we're doing regression with a time series. See, this is a time series. When we did regression, we never had these words right here, or like January, February, March, April. Even if you have like 1982, 1983, 1984, technically they are not values that you do math on. It's just the year, right? So what we're going to have to do when we do this is we're going to say the solution, when you're given something like this, is to turn this column right here into a column that deals with numbers that suggest succession or consecutive, or a consecutive nature, right? So you remember when we did the EWMA, this value right here was when t equals 0, time equals 0. Then this was like t equals 1. Then this was t equals 2. Then this was t equals 3. This is what helped us in the EWMA when we said like E of 1 is equal to lambda times this, that first time period, plus 1 minus lambda times the value right above it. Well, what we did was we didn't think about these as being words. We thought about them now was when time was 0, or when time was 1, or when time was 2. So what I'm going to have to do, the solution to doing a regression, is first of all, transform this time column here to something like this. Alias, ALIAS, time, right? Alias just simply means like another way of thinking about time. Like sometimes people have an alias name, right? It's not their name, it's like a pen name, or sometimes writers write under a different name, a pen name, right? So I'm just going to say this: 0, 1, 2, 3. So again, this is just another way of saying Monday, Tuesday, Wednesday, Thursday. See, time equals 0, that's Monday. Time equals 1, that's Tuesday. So now once I write, and this goes across the board. If this is January, February, March, April, same thing. 0, 1, 2, 3, whatever. And now the data is still going to be what it was. See? All right. So now I'm in a position where, oh, okay, now I can do a regression now, because now this is going to be my X that I put in, and this is going to be my Y. Now, when it comes to interpreting that stuff, that's going to be a different story. And I think what I'm going to do is, yeah, use the regression equation. Okay, right, yeah. So let me slow down a little bit. Does everybody kind of see what I did from here to here, right? Because we want to use time series to do a regression and to predict one point into the future, but I cannot do that until I at least change the X column into some type of system that shows numbers. So if it's given in months, this would be alias month. If it's given in years, this would be alias year. But it's always going to be 0, 1, 2, 3, all the way to the end. Okay? All right. And so now I'm going to say, here's what I'm going to say here. So what I'm going to say is, from here, when I'm regression, using this as my Y column, this is my X, I'm going to say, of course, the equation is going to look like Y sub L equals MX plus B. Here we're back to the regular kind of system because I only have one X column and one Y column. And then I got to do something really, really special. And the best way to show you is to actually do it on Excel. All right, so let's move forward. This is, let's see, can you guys hear me? I just want to make sure the setup is okay. Are you guys able to hear and see me?
Yes.
Okay, all right. So let's get this here. Ugh. All right, so you have this weekly NASDAQ data set here. And of course, you want to have me over to the side and you have your own there that you're kind of looking at. So notice here that we have a time series. How do you know it's a time series? Because you have this information here that's suggesting time. Okay, let me move this over here. All right, so as I stated before, I want to create a column that says alias week, or whatever, however the data is presented. If it's year or if it's days or months, and you say alias day or month. So I'm going to say, I'm always going to start with 0 here. And then I have 1, 2, and then just find a way to make it go all the way to the end. You can either put them in all manually or just highlight the first 2 and then stop there. So looks like it's stopping at 19. And then this column here, NASDAQ, that's our original data column. I'm just going to copy and paste that right beside it. Okay, all right. So now I'm able to do a time series. I'm able to do a regression on it. You guys remember how to do a regression? So I'm going to go where? I'm going to go to data. And over here to the right, you should have that two-pack, data analysis two-pack. So I'm going to click on that, data analysis. Now we want to go to regression right here, regression. Okay. All right, and so this is just like a regular regression that we should know how to do for exam 1. We only have one Y column. And remember, the Y column is always the column that has the data in it in terms of whether it's sales or revenue. In this case, it's NASDAQ. So I'm going to click the cursor here, and I'm going to include the word NASDAQ and then just scroll all the way down to the end there. All right, then I'm going to click and input X range. So in a time series, the X range, remember, is like the weeks or the month, but I need to make sure I do the alias, not the original, because see, it's going to give you an error. You know, how do you do regression on, you know, March? You can't. Now click on labels here, click on labels. And then I want my output to be on the same page. If you don't want to put on the same page, then you can just click OK and it'll put it on another worksheet. But I want mine on the same page. So let's see. Well, yeah, so click on output range, and then just make sure the cursor is blinking inside of the cell right beside it. And then just go where on here that you want to your results to show up. And I'm just choosing that cell right there. There's nothing special about it. Now let's see what happens when we do OK. It's going a little slow, but okay. So here's my output. Is everybody able to get your own output there? See if it matches mine. I'm just going to spread it out a little bit. But remember, we chose NASDAQ for Y, and then for the X, we chose the alias week column and then those numbers there. Does your output match mine? You guys have this? Does your output match? Like look down at, in particular, coefficients down at the bottom. You guys have the same numbers there?
Yes.
All right, well, okay, great. So now, so this is the biggest hurdle, right? Because now what we want to do is predict. Now in this problem, let's say if I do something like this, I say predict the NASDAQ value that corresponds to, let's see, this is our weekly. So the next time point here, I guess would be May 22nd. 06. This is the old data set, right? So you guys see where we're going with this? So a question in this regard would say predict the blankety blank value that corresponds to blank. And that corresponds to blank represents T plus 1. T plus 1 in this case is the next week after that. So May 15th, I just add 7 to that, and so that's May 22nd. Now, how are we going to do this? If you had to write, let's say, y sub L equals, and if this is not, let's see, I'm sorry, I'm gonna make this a little bigger. I'm sorry, give me 1 second. I want to zoom in a little more. Okay, all right. Okay, so our regression equation, anybody think they know what the regression equation is going to look like in this scenario? It's exactly what you may think. So in other words, I know we dealt with regression later, but we're coming back to regression with time series. Anybody think they can look at this and tell me what you think the regression equation is for this time series data? Just based on what you think you know. Y sub L equals what? Nobody? Like how, because see, this is kind of good review for the exam too. Okay, well, Y sub L equals, I'm going to say 0. And my eyes are going here. All the information I need for the regression equation is going to be right there. So 1 minute. All right, so my Y sub L equals 0.368. I'm just going to just stop it there. X plus 2291. And I don't know. I don't care how many decimals. So that's my regression equation. And I'm only going to be able to predict based on this regression equation. All right. Now, I need to predict. I need to predict. Well, based on what I know, I can predict. You see that x in the equation, 0.368x. Well, what does x correspond to? The alias week. Where does the alias week stop according to the new column that we can? Do you see how the week stops at observation number 19? Well, the one after that, see right here, 19. Well, t plus 1, or the next time point, represents this. See that 20? So what I'm doing, so essentially what I want to predict, I'm going to be using this number as my x, because it represents one more than, and you may say, wait a minute, why I say 19 and then 20? Well, to be honest, you see how it starts here at 0? So it really is 20 of them, right? But I always have to start the first data set or the first data point at t equals 0. That's why it looks like it's only 19, right? So when I want to predict one time into the point in the future, I'm going to use this into my x. All right. So we're going to have prediction. And over here, I'm going to say equals. I'm going to put in a function. Well, it's going to be m, which is here. So I click on that, times the x that represents one time point in the future, which is here, plus my y. See, y equals mx plus b. And then boom, there you go. That's my prediction for the time point, one time point outside of my data. So essentially, I am predicting using time series and the alias value there. Yes.
Can you just do that one more time? Sorry.
Sure. Okay. So I want to predict, knowing that this is my regression equation. I mean, I can type that separately if you want, but essentially, I'm going to use that form to help me predict. So I'm going to say equals. Then I'm going to type, I'm going to click on the slope, just here, m times. I'm going to put in the value that represents one time point outside of my alias week. So one time point outside of my alias week is 19 plus 1, or this number right here. It's always going to be right here. Plus y-intercept, which is here. Boom. So I predict that, what is this data about? Let me see. That's that. I predict that on May 22nd, according to regression, I predict that the value, NASDAQ value, will be 229, and I guess I say take it 2 decimals. You know, you can make it 2 decimals if you want. And I'm up here. This increases or decreases decimals. You can say it's 2299. Oh, oops, one more. 0.01. Very simple, just simple as that. So this is using regression methods. Again, we went over how to do it with EWMA, and I'm not really going to focus on that right now, but this would assume you have like an EWMA column and all that stuff. So you can predict using EWMA or this right here. Now, let's figure out, these are the last two things we're going to learn this semester. Interpreting the slope. So let's go down here. Any questions on that? Everybody okay with that? Now let's say interpret the slope. Right? Now, when we interpret the slope here, again, this is with time series, using regression with time series. By the way, anybody want to follow me? This is page 511. See, pages 511 to 513. 511 to 513. Everything we're going over now. The alias half year, the regression output, and how to interpret the slope and the y-intercept in a time series. Okay, Interpret the slope. Can anybody tell me what the slope is here? Here's my equation. Which one of those numbers represents the slope? Anybody know? Which one of these is the slope? Good. 8, right? So I'm going to say m equals 0.368. Now, how do I interpret that? Now, stating it is not interpreting it. Interpreting it. Well, what is m is delta y over delta x. My y here is NASDAQ. My x here are weeks. Weeks. So I'm going to say, because normally we say for every one something, such and such and such and such. So I could say for every 1 week, or I'm just going to say every week, comma. See, it's like 0.368 over 1. I'm sorry, let me see something. So really the m value is this over 1. Okay? So I can say for every 1 week, or I can say every week. Okay, so I'll let you choose what you want to do on that. But you can either say for every 1 week, or I'm just going to say every 1 week or every week, the NASDAQ value is expected to increase by 0.368. See that? See that? So what I did was figure out what the slope was, and then interpret it in terms of how we normally do. But the only change here is that your y value now is always going to be a reflection of time, right? So you can say for every 1 week, the NASDAQ value, blah, 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 blah. Or you can say every week, the NASDAQ value is expected to increase by 0.368. Okay, how about the y-intercept? Interpret the y-intercept. All right. Pull this out a little bit. All right, well, what is our y-intercept? Our y-intercept is b equals 2291.65. So that's what it is. That's what it is. Now I need to interpret it. And again, this is on pretty much on page 513, both of what I'm going through. So if you need to write down a page reference to look at later, that's fine. Well, how do we interpret our y-intercept? The y-intercept, remember, is always technically 0, 2291.65. I mean, technically, right? And the only reason I did that is because I need to know how to interpret the 0 and the 2291. Well, in the case here, let's see, 0 here means t equals 0, right? T equals 0. And what data point on here in reference to time references t equals 0? The earliest value when t equals 0 corresponds to what date or what point in time? Is that like February? I didn't go. What's that first?
I think it's January 3rd.
Okay, is January 3rd, 2006? January 3rd?
Yeah.
Okay. In other words, just go back up to the top. I just didn't scroll back up. So it's that data point that corresponds to where t equals 0 for alias. Okay. So I'm going to say for January 3rd, 2006, our NASDAQ value is predicted to be 2291.65. Okay, so in other words, I have to interpret that 0 and then the actual y-intercept. You may be saying, wait a minute, that's stupid, because all I got to do is just look on the table and I see it's not 2291. Is what? 23056 is this. See, you're saying is this right here. Well, that's the thing with regression. With regression, it's taking into account all of those values, right, together. So when I get down here, this may or may not necessarily be the actual value. So you have an actual value and you have a predicted value, okay? So I don't want that to confuse you too much. It's just that we're saying when you look at all the data together, that actual regression line, when you put it over the data, may not necessarily touch the actual point. So I'm going to say for January 3rd, our NASDAQ value is predicted to be that particular number there. Okay, so we have an interpretation of the slope and interpretation of the y-intercept when we're using regression with time series. But notice the wording here for slope, I'm saying like increase by or decrease by, whereas here I'm saying it's predicted to be that particular number itself. I don't have to worry about whether 0 is in the range necessarily, because it clearly is when it's that first number t equals 0 there. Any questions on that? Any questions? Any questions?